Okay, welcome to the last talk, the last regular talk at least in this room. I think we're all somewhat in chill-out atmosphere, and our friend Psychoduck from the Neo Army has suggested we just chill out, have
Yo!
and look some little bit into fingerprinting. We heard a lot of fingerprinting just before, and we'll now look more to the application layer. We'll see some tools, see some problems, nothing groundbreaking, but there's so much stuff about fingerprinting we didn't knew before we looked into that problem, and probably some of that you don't know, and we'll show you some of the things and some of the new things we developed. We promised to release our new fingerprinting engine at this lecture, but basically we didn't manage to pull all the code we've written on fingerprinting together, so we are releasing a bunch of tools, but not the great unified solution of all application layer fingerprinting tools. You have to write that yourself. Okay, here we go. I myself from the Laboratory of Dependable Distributed Systems, and we all three, Ilya from Sprondel, and Psychodoc, met at the summer school, applied IT security in Aachen, which we all three and all other participants enjoyed very much. And there we did several workshops and sessions and lectures on fingerprinting and wrote a lot of code, and now let you participate. We'll have another summer school next year, which will be great fun too, and if you are interested to participate, surf to the URL on the bottom of the slide, add you to the mailing list, and when we'll know the exact date, we'll send out a mailing and you can apply to be there. It's even free and fun. And a lot of work. You are expected to work around 20 hours a day for 3 weeks.
He's not lying.
Yeah. Ilya was not sleeping all the time. Okay. So, what is fingerprinting? We'll have a very short look into that because we just had a lecture on fingerprinting in this room. Then we'll look. No, we won't look into TCP IP stack fingerprinting. I've thrown all the slides away when I saw that there's a TCP IP stack fingerprinting presentation just before ours. And then we'll look into application fingerprinting, show some of the more obscure tools. All in all, application level fingerprinting isn't that well known. Everybody knows that Nmap has an option for TCP stack fingerprinting, and there are tools like POF, or Xprobe, which do TCP stack fingerprinting, but application fingerprinting is not that well known, and there are banner grabbing tools, but there are a lot of obscure tools. And we think application fingerprinting is more fun. Drinking non-Cologne beer is so difficult. You should all drink Cologne, beer from Cologne. Okay, fingerprinting. There are several things to fingerprint. People come to mind at first. That's quite usual. IP stack fingerprinting is quite common too. We're looking into application fingerprinting, and people often forget about what to fingerprint exactly. You can fingerprint clients. And in fact, it seems that the first approaches on the Unix security community were fingerprinting clients. And you can fingerprint servers. That's the thing most people do by doing TCP connections or connecting to mail servers or whatever. What is fingerprinting at all? It's comparing features which make something identifiable. It's very seldom an exact science. So, for example, the fingerprints police use of humans, they say there's no chance that two fingerprints are identical, but it is, and the comparison is not an exact science. You can't do just compare two images, but you have to extract which features you want to care about and which to throw away and scale that and change that. So fingerprinting is always somewhat fuzzy, And the value of fingerprinting is in the databases to match against. That's the reason when we started to use genetic fingerprinting in the last few years, that near crime cases, all somewhat suspect persons, usual males, were asked to give genetic material to build that database and then use it for fingerprinting with and comparison in the fingerprinting process with genetic material found at the victim or something else. And that's the reason why the police is keeping fingerprint databases for years now, for centuries now. And that's the reason why the value in fingerprinting tools is very much in the databases they have to match against. That means that a private fingerprinting tool is of very little value. There's really good reason to make your fingerprinting tool publicly available and encourage people to submit additional content to the database. Okay, TCP stack fingerprinting, you've just seen that. Application fingerprinting. First, the tool for doing application level fingerprinting by hand is SOCAT. Many of you might knew Netcat, but SOCAT is so much more feature rich and so much more logical to use. It's like if you compare the tool set delivered with one of the first Unix versions with the tools now available to a modern free Unix distribution. Some people claim that Netcat is the Texas chainsaw of networking, then SOCAT is the Texas, the Swiss chainsaw of networking. If so, SOCAT is a Swiss Army, whatever, the great thing of networking. It can really do anything which can be abstracted by a file or a socket on Unix with PDIs and so on. You can really do a lot of nifty stuff. The most simple way of fingerprinting is banner grabbing. Sometimes you don't even need a database if the banner contains the name of the server. But there are more interactive approaches. Okay, banner grabbing is simple. Connect, get the response, disconnect, hope nothing breaks in that process. Interestingly, some servers break in this process because they ask you or they expect you to say goodbye before you disconnect, but such software is very seldom on the internet nowadays, and works very nice for many protocols. For example, many people are not available that very simple banner grabbing is available for SSH. So SSH is a binary protocol, no banners there. Yeah, you're right, but before the binary handshake starts, there is a clear text banner, and for some reason programmers have a high tendency to put all kinds of information in the banner for debugging or whatever. So FreeBSD has a tendency to announce the exact version, even with the date, so you can be sure if something has to be exploited, can be still exploited or not, or is patched. Some people patch the banner to read something special. Some other people put in the distribution and the exact version in the Linux community, and there are even other things like all of the upper examples were OpenSSH. There is SSH, the commercial version, and if you go on scanning for stuff, you also find some very interesting implementations you're probably not aware of the SSH protocol. A very nice tool for grabbing SSH banners is Ssh Scan from Niels Purvers. Niels Purvers writes very good network programs, and Scan SSH is a very good implementation of that. And that's just some example of scanning a random network of an SDSL provider. And while the first few SSH versions, I can understand what that is. I have no idea what ASL OpenSSH is, and I don't know what the SSH protocol compatible server SCS20 is. Probably something to look into if you're looking for some usual software which wasn't researched that well for security vulnerabilities. So by just grabbing banners, you can find out a lot of certain protocols, even meant to be secure protocols like SSH. And the other nice example is FTP. Here we have an example where NCFTP even puts the licensing in the banner. What matters that for the other side of the network? What license does a server uses? But that's in there. And we'll find commercial FTP sites which have a non-commercial license in their banner and stuff like that. Other things identify very nicely their version. And if you are once into connecting to FTP servers, before disconnecting, you might try the syst command. That's the first part or the first step where we leave just banner grabbing and asking for more information for the system. The FTP syst command doesn't deliver that nice information, so it's BSD44, that can be anything nearly. But at least you get some more information to understand what's running on the other side of the network connection. With a wonderful SOCAT tool, you also can do a large-scale banner grabbing. Just download a few pages which contain lists of FTP servers, for example, mirror sites of Unix distributions. Use a little bit Perl, pipe that all in SOCAT, and you have a file with a lot of banners to look for interesting servers. Perhaps they are interesting because you want to look what files are on there. Perhaps they are interesting because they are obscure software you want to play with.
Telnet is an interesting protocol for fingerprinting because it is an awful lot more complex than most people think it is. When you just telnet into things, you normally just see the username, but the things that you don't see are the more interesting. When you make a telnet connection, there's a thing that happens which is called session negotiation, which allows you to set an awful lot of interesting properties, such as set environment variables or echo all the stuff you throw at them, or a number of other things, which you can just look at in the RFC. Because of this session negotiation, almost any telnet daemon will, or almost any telnet daemon on different operating systems will give you different responses. So that makes it an ideal protocol for fingerprinting. Yes. Okay, I suppose we're first going to look at banner grabbing. Oh, this is another nice SOCAT thingy that Max made. Maybe you should give some explanation about that, because you probably understand it better than I do.
I think that's the FTP slide, and probably
I hit the wrong button?
or the computer fell down and the slides got mixed up, or something like that.
Yes, I hit the wrong button. I'm an idiot. So we are first going to look at thank you. We are first going to look at banner grabbing. Here you can see that if you make a simple connection to a telnet server, the first thing you will get is some binary data instead of the banner. If you make the connection again and you actually use Telnet, you don't see the ugly binary data, but you see the actual banner. So, yeah.
I think that's very important to state. Many people use Telnet as a generic network connection tool, but the Telnet client utility does a lot of stuff behind the scenes. And you see, if you use a generic network connection tool like SOCAT to connect to a Telnet server, you actually get completely different output than you get by using Telnet to connect to a Telnet port. That's something to keep in mind when playing around with Telnet, and usually Telnet clients are built in a way that if you connect to the Telnet port 23, they play Telnet protocol, and if you connect to another port, they act as a netcat emulation or something like that. But keep in mind, Telnet is no generic and no 8-bit clean network connection utility. Stay away from it if you don't want to use actually Telnet protocol.
Yes, here you can see again a lot of the binary data which Telnet uses. And underneath you can see the banner or just the the string you get that asks for your passwords. This is a bit more of all the same. Again, the banner. Yeah. Okay. Yes, this is all about the same stuff, I suppose. Or is there something that I'm missing?
No, it's just different between different servers. They have a very different behavior with login. For example, in this slide, I just connected and did nothing. So after 60 seconds, I get a password, timeout expired. After another 60 seconds too, third time, it disconnects. Other servers wait for a password forever. So the behavior when just connecting between different servers is very different.
Yes, which is what you can see here. Okay.
That's actually my printer, who has a very strange password prompt.
Okay, this is an interesting thing that I found a while ago. This is actually an AS400, running OS400, that I accidentally found while crawling Google for interesting targets for Telnet fingerprinting. I think it's quite interesting. Unfortunately, while we were testing this thing again, because we wanted to show this on a demo, but while we were testing this earlier, we noticed that that screen is not there, the login thing isn't there anymore. So unfortunately, we couldn't give the demo. Yes. The more interesting things about the Telnet protocol is that it will basically have 4 basic commands, which is will, won't, do, and don't. Because basically, Telnet protocol works on a where you just send a query and then you get a response to it, and that's the way it works until the entire session negotiation is done, and then the banner happens, and you can just do, and you just get to see the what you usually see happens then. The Telnet FP is actually a pretty cool program written by Palmers of Tesso. The database is fairly old, as you can see here. Updating database on itself isn't that easy. I've tried a few times, and if you don't do it exactly the way it was intended, oh, I am an idiot. Yes.
The problem is on our screen, we see the whole slide already. It's a bug. We should report that to Apple.
Yes. So, as you can see here, the database is rather outdated. And updating database isn't as easy as you would think, but eventually it works out.
So basically, that's just to show off that the database of Nmap looks more current, but then again also it's a little bit contradicting because it claims the Telnet D is from AIX and the FTP daemon is from HPUX. what might be possible, but strange combination on the same machine. I think this machine is actually a sun, to my knowledge. Yeah, it could, but we know the operators.
Okay. Oh, I think I hit the wrong button again.
No, that's
Oh,
poor Ilya has to show the slides I created, and he never saw them before.
yes, which is kind of a problem.
Okay, that's basically the same machine. If you turn it to it, oh, it's an AIX. Sorry, no sun. It says which version it is, but you can't deduct it with the fingerprinting tools. Is there a question already? I just saw something. Yeah, we could. Oh no, you show me. You don't have a question. Very nice. Okay. So we can see here Telnet FP has already the ability to do some fuzzy kind of matching. For example, for this machine, it has a very wide range of operating systems. This might be. If you're looking for strange hardware to fingerprint, usually the address ranges used by SDSL providers are very good for harvesting that stuff, because many little bit sophisticated businesses rent an SDSL line to their offices and have some obscure equipment there, and just go look for the biggest SDSL advertisement or business ADSL with fixed IP and scan that address ranges to find lots of strange stuff to fingerprint. So here again we see Nmap and Telnet FP disagree heavily. That's probably the problem of the Telnet FP database being extremely old. What Telnet FP actually is doing, it checks which options the server categorically says it won't accept and which one it would accept. And since you see there are a lot of options in the Telnet protocol, and they can even be seen in combinations depending on what the client sends, there's quite a lot of space for fingerprinted. This actually is a part of the fingerprint database used by Telnet FP. And you see they have, while the fingerprint database is very old, it has support for even quite obscure things like Linux with support for secure ID cards. I didn't know that Telnet was different there.
Yes, ident is a rather simple protocol, which there are two tools for, apparently, to fingerprint. One is ident FP by Deity of Synergy, and the other is eldest FP, which you can find at PacketStorm. The above comment is false, by the way. ident FP is not a lost tool. It can be found. It's just that apparently the Synergy guys have reorganized their website. Okay, I got it right now. This is a small example of when you do things manually, of what you get.
So many different ident servers send back very different answers to, for example, version requests. We use SOCAT here to convert the new lines to the way ident protocol wants it. And an example is for in the third connection, I sent the version request. The server sent an answer, but did not disconnect. While in the first two connections, the server disconnected after it sent an answer. That's something to fingerprint on, and you still could fingerprint on the different answers seen. For example, the fourth request now sends a quite strange and non-standard answer. The University of Berlin sends a very extensive answer, far more we ever wanted to ask for, even with compile time of the software. Other identity versions do that too. And then again, this identity didn't answer at all. It just closed the connection after the version request.
Right, FTP-map, which is one of the tools that we've extended, so I can tell you something about that. It is written by the Jedi1, which is the guy who also made pure FTPD. This is the way it looks like when you run it, or this is the way it used to look like when you run it. Basically, what it'll do is it'll send out a lot of probes and just make hash of every reply it gets, and those are the numbers that you see. And afterwards, it'll match them against a huge database that it has, and it'll even do it'll look for the one which looks the most like one database. So, and the cool thing is that next to it, you see by how much it was off.
But in this case, it was very off, because this again was my poor brother printer, and not a pure FTPD on the brother printer.
But that was, well, I believe that it was mostly due to not enough fingerprints in the database.
So we fixed that.
I don't think we fixed it for the printer, but we fixed it for a lot of other things, because the tool is about 3 years old, and there was quite a lot of development in FTPDs and stuff in the last 3 years. Yes, this is the way the fingerprints used to look like. It was hard-coded. Yes, yeah, I will say something about that. Next slide, I suppose. These are the probes that it sends. This is only but a small bit from the actual header. It sends about 150 probes when not logged in, and then it logs in or tries to log in, and sends the 150 probes again. So it sends about 300 probes. So this will make noise. Yes, this is the update that I've made. The previous version, the one that we've described, was 0.4, and the update basically has an actual database, which is far more easy to update now. It also checks if you can't log in, and it will print a warning message saying that the fingerprint might be less reliable because you can't log in. Previously, it also had a bug that it would do IP version 6 and 4, regardless of your computer supporting it or not. Yes, the output you got. Oh. That's it? Oh, wait a minute. I want to go back.
Oh, we don't have an output of the new tool.
Yes, but we have an output of the old tool. So the, the output that you see here, the numbers, is fairly annoying because it doesn't fit on your screen. That is somewhat improved, and it should fit on the screen now.
So even good user interface improvements.
Yes, somewhat. Yes, the fingerprint database got doubled. A few annoying bugs also got fixed, and in about 10 minutes or so, you should be able to download FTP-map 0.5 if you're interested.
Okay. Then there's Smtp Scan, and there's a very nice paper describing it. Smtp Scan works very similar to FTP-map. We see here example output of it. We will see. Okay, you start it to run against one or several domains, and that's one of the things which make SMTP-map a quite polished, SMTP Scan, a quite polished product. You can run it against several domains at once. You can say if it should take all MX records from that domain or just the highest priority MX records to connect to and test the things. And then sends a set of probes, which is defined in an in an external file by doing borderline cases in the SMTP protocol, and records the return codes of the answers. It doesn't record the text in the answers, so if somebody changes this text, that doesn't help at all. It just returns the return codes. And to change the return codes of a server, you usually have to change a lot of the internal logic of that server. So it's not easy to defeat SMTP Scan. In this case, it correctly identifies these two servers. SMTP Scan comes with a huge database, which basically has the server, the name of the server and the return codes sent back, and an additional file describing the tests. These test commands are sent to the servers, and that the return codes are analyzed and compared to the database. SMTP Scan seems to have been integrated in Nessus, but and the Nessus version seems to have even more fingerprints. But then again, it seems that the Nessus people have deactivated it or something like that. I'm not really into the Nessus plugin development thing to understand what's happening there, but on this URL, on the Nessus CGI server, you can find a somewhat updated version of SMTP Scan, at least of the fingerprint database, although it's in the nasty NASL language. But then again, SMTP Scan itself, it's in Perl, and that's not less nasty. Another thing is Lpd Fingerprinting, which is described in a paper by Phobic. The problem is that, how old is this paper? 5 years or something like that?
I think about 4 years, I think.
And basically there's code of proof of concept code. But one of the problems is that it has a very tiny fingerprint database. That is the complete database. But it basically tests Lpd servers, what error messages they send. But because of the database is so small, it doesn't work out. And when I tested it again against my poor printer, which has an Lpd server, I'm quite sure, okay. Here I tested it against my poor printer. It hung. I had to use Control-C to stop it. Okay, DNS. DNS is quite interesting because it's a binary-only protocol, or next to binary-only protocol. And interestingly, the programmers of DNS servers, or at least that certain DNS servers, have the tendency to put Easter eggs into their servers. So if you use very special queries at a server, you get already the version information back. For example, if you query one of the root servers for the domain version.bind, in the not in the internet domain, which is IN, but in the chaos, chaos was not developed by the Chaos Computer Club, but this chaos was developed at the MIT as a networking standard, which isn't used that much anymore. But if you request a text record there, you get the version information back. And while you can disable that in newer versions of bind, people just don't do, like you see, even the root servers don't have that disabled. But there are more Easter eggs. The root server also gives you a list of authors of the DNS server, which is obviously something you can fingerprint on. Other DNS servers which try to be a replacement of the bind server thought, oh, we have to replace this functionality too. Use other names, but still have the version, have strings identifying the software and the version. Another thing is you can use for fingerprinting the way zone files are edited. For example, the DJB DNS suite or DNS cache suite, I don't know which is the actual name, he changed it once, have a tendency to have double records in the DNS database. So for a single query, you get back two answers with the same content. If that happens, you can be quite sure that you have a somewhat stock setup of the DJB DNS suite. People could remove these duplicate records by doing filtering on the DNS database before publishing them, but they usually don't do. There's a nice overview from Dan Bernstein on DNS fingerprinting, and he even has a nice list of which fingerprints identify which DNS servers. This is implemented in Nessos one-to-one. And in the summer school, we actually had one of the works the students had to do was write a tool which passed the web page of Dan Bernstein to get the fingerprints and then used that for fingerprinting. And it royally pissed off the students. We aren't here to write parsers of stinky HTML. We want to hack machines. We never do such an assignment again. Okay.
Incidentally, one of the guys from CCC who was there as well did do this, and he made a pretty cool Perl script for it.
Yeah, but I think we forgot to put it on the web page. We will. So the URL at the end of this lecture, I will put the DNS fingerprinting tool from the summer school up there too. And the DNS fingerprinting as described by Bernstein is available in Nessus, but there are also other tools. For example, DNS Finger, which was published on the Dark Lab mailing list. There's somewhat related THC bind info. DNS Finger has the interesting property that it is, I think, was it remotely exploitable or not?
No, you could crash it remotely, but you couldn't exploit it.
But with DNS Finger, we show up some interesting things. Here you see that DNS Finger is still early alpha. The version string with the brackets in it, it's a bug in the tool. Nmap can also do some DNS fingerprinting and it's correctly identifying this DNS server as ISC bind. Here again, that's quite interesting. NetCologne identifies itself, if you look for the version string, as NetCologne is a big internet provider in Cologne, as NetCologne name server. So I think, how lame is that? Take a stock bind, as we've seen, bind 923, and just rename it as NetCologne name server. I think the ISC could sue them for mislabeling. You know, you can't. You don't think so? I think it's a BSD license which explicitly claims that you don't have are not allowed to claim that's your software. But nevertheless, I think they won't do. But I think it's extremely lame by the NetCologne people. We can be sure of that. Yeah, but as told with DNS Finger, if you go around the net and just fingerprint random machines, things like that happen. I got scared and stopped using that software. Okay, and there's Fpdns. Oh. I should tell you, you should use the microphone if you're asking something. I'm very glad I'm not being told that I should repeat your questions, which I forget all the time. Okay, there's also Fpdns, which is a quite decent tool. It seems still to be maintained. It uses a decision tree. That means it doesn't throw all possible tests at the server and then analyzes the results, but use only the special tests used to decide is it that version or this group of versions or that group of versions, and then uses handcrafted tests to finally come to the result that it's a certain server. The problem is that decision trees are very hard to update. So if you want to add another server to that decision tree, you might end up with a total rewrite of the tool. It's available from Sweden, and it's a good tool. Output looks like this. I just tried a lot of servers, and wherever I knew the results were correct, although with certain servers there were certain problems with this Q0T, Q0T, and so on. But all in all, it's the nicest DNS fingerprinting tool to have. It also gives you information if it's just a normal DNS server or a DNS server which publishes information, or also works as a DNS cache, allowing you to do recursive queries on there. Okay, and a very interesting thing which hasn't been researched that much to my knowledge up to now is multicast DNS. There are several names. It's marketed under Apple probably is most famous with the name Rendezvous, IP version 4 LL local link, zeroconf, multicast DNS. There's a nice webpage at .local.org describing the whole thing. And especially Macs are extremely chatty when speaking multicast DNS. Multicast DNS is happening on port 5353. If you just try to use a DNS querying tool, it doesn't work out. You basically can't use the local address, but if you use the multicast address on your machine, you get an answer. Coldcut local is the multicast DNS name of my machine. And you see in there is a lot of information, for example, the model number, it's a PowerBook 3 version 5, the operating system number, the exact version of the multicast DNS software, all kinds of IP version 4 and version 6 records. If you ask for other names identifying other services on that notebook, you get information that there's an SSH day running, the name of the machine, Coldcut, the MAC address of the machine, but also, for example, the version of my iPhoto software and iTunes software, and if you can request things there, lots of stuff. One thing is that seemingly, since it's multicast, on a multicast local network, you can't do that over the internet. But it would be extremely nifty if somebody looks deeper into that and if one could get all this information, like MAC address and installed iPhoto and iTunes software and so on over the internet. That again, that's the information from my Airport Express, which also sends out a lot of stuff. And more information available via multicast DNS. Chat information if I'm online. Multicast DNS, the draft of the protocol says that all the information should basically check, or the servers should check if the TTL is still with 255, and so to be sure that the information is not requested from a machine which is several hops away. That's basically the main obstacle in using multicast DNS over the internet to get information out of a machine. But there may be ways to get around that in the implementation by Apple. Okay, something completely different is Ike Scan. I think we're getting somewhat short on time. In many scenarios, if you are looking to a company which has hardened their internet border, you have SMTP because they need that to get mail. You might have HTTP if they don't host their websites somewhere externally. And you have their virtual private networking way connections and IPsec stuff. And there often the Ike port is open. And Ike Scan, Ike Scan is an interesting tool. I think it was published this spring, or is it older?
I have no idea.
Okay, it's not that old. And it can fingerprint the Ike protocol implementations used to do the IPsec setup. So that's quite interesting stuff. If even if a company is very well hardened, you might be able with Ike Scan to find at least out the software of the VPN router, and that might point a stepping stone to get further into the company, or at least if you have to write a report on that to impress them. We know that your firewall 1 version that is very well configured. Okay, there are several tools. We have now seen tools which were only for a single protocol, several tools who try to integrate that. Probably the first one was Vmap, which does more or less banner grabbing in a little bit sophisticated way. If you want to test that on macOS, you need a patch available at that URL. Nmap is from the same people and much more advanced. And finally, Nmap, since version 3.5, has application layer fingerprinting too. A short look at Nmap, running against the server. The information isn't that detailed. Before, we did banner grabbing, as you might remember, on that machine, and got a lot more information than that it might be an OpenSSH daemon on the SSH port. But that might be just a problem that the fingerprint database isn't that well developed and that big. Nmap has the concept of triggers, so it sends certain information to ports like user Nmap or hello Nmap, and then has a database where the replies to that triggers are mapped to certain servers. So, for example, that's small. A good example is for the finger. These are the replies sent by different finger servers when being requested some more or less random string by Nmap. For the HTTP servers, the error message is fingerprinted, or since the triggers also contain HTTP requests, even more is fingerprinted, like part of the HTML page, as you see in the last line, where the get direct default answer to a request, one of the requests Nmap sends is non-supported in the title. Nmap works quite similarly, gets better results. Now, Nmap again, running against the same server, you see it identifies the SSH protocol or the SSH server, for example, much more detailed. But then again, it's wrong. I'm quite sure that's not VuFTPD running there. Again, because I know the guy running the machine and he would never do that. He would.
And because the version is wrong, there's no VuFTPD 6.
Oh, yeah. How do they come to put that in the fingerprint file then?
I have no idea.
I read wrong.
But it looks...
Fun?
Yeah, it looks like a combination of VuFTPD and BSD1. Okay,
there's a quite long explanation by Fyodor on the Nmap version scanning, how it works. Basically, it's again the concept of triggers, which are sent on certain conditions, and then matching for the answers. So, for example, you see if it's welcome to pure FTPD. Nmap assumes that it is a pure FTPD there, and sends again more FTP requests there to further identify the version. The Nmap application layer probe file is very huge, and because of the massive use of Perl regular expressions, or Perl-like regular expressions, it's no fun to read, but it's quite educational to understand what's happening there and to look into that. For example, with clear text protocols, it's somewhat still fun, but they also have fingerprints in there for binary protocols like SQL Server and DNS. Oh, that's another part of the probe file. Okay. That is from the slides of advanced techniques. We won't go into that. Then you might be able to fingerprint attempts, or you might be able to use the fingerprint databases to fall fingerprint tools. Since you know exactly what they are looking for, you can send them what you want them to see. The most famous example is probably HoneyD. In the lecture before, we heard about the IP stack identity module for the Linux kernel, which somewhat works the same way. HoneyD can simulate one or more IP stacks. I think it was tested with several 10,000 IP stacks emulated at the same time. And it uses the databases of fingerprinting tools to emulate the IP stack. So basically it gets the databases of Nmap, Xprobe, and POF. And you say, I want to simulate something which has the same fingerprint for Nmap, Xprobe, and POF. And then it adjusts its IP stack behavior, it's no real IP stack, accordingly to look as one of the operating systems you simulate there. We tried to take that some further and said we are more interested in applications, and many people are trying to simulate applications with HoneyD by writing shell scripts which are started by HoneyD if somebody tries to connect to a certain port, and then use shell commands to simulate a web server or mail server. And we said, why shouldn't we turn around or take the approach for the HoneyD takes for the IP stack and use it for the application layer. And basically Ilya did a proof of concept code in one night. You know, he wasn't allowed to sleep during the summer school. To use the database by Vmap and attach it to HoneyD to simulate the services Vmap knows. And so when scanning Vmap, it's exactly was the same way as Nmap, POF, and Xprobe. It saw exactly the replies it was looking for. Do you want to further elaborate on the problems or so?
It was AMAP and not Vmap.
Oh, that's very good. Okay, then I took a student and thought, oh, he might need half a year to replicate that work of Ilya, and gave him Vmap to do the emulation. And so, to my astonishment, we now are able, if I drag out Ilya's code, to foil Vmap and AMAP. Very good. So we still have to add Nmap to that. The whole process, especially with the Nmap, is quite difficult because there are so many regular expressions in the database, and you basically have to find something which matches this regular expression, but also matches the fixed strings used by Vmap and AMAP. But yeah, computer science faculty, people should know how to do that. The initial code now for AMAP simulation is written by a student at the Laboratory for Dependable Distributed Systems, Thomas Appel, and he was so friendly to publish it. So you can download it at core23nu and this URL. It's also linked on the page with the slides we'll see in the end, and then simulate happily everything for Vmap. We'll come up with more code in that direction to automatically simulate services with HoneyD applications. You can expect quite a lot of stuff more we have in the pipeline at the laboratory there. Okay, in the summer school, after we did 3 hours of lecture on fingerprinting, we were told that we are so stupid and doing it all wrong and have to rethink the whole process because fingerprints or the probes sent and the answers sent back, the probes sent are more or less handcrafted, and then the answers are collected, and it's a very manual process, like a cottage industry or craftsman. And we should look into others who fingerprint. For example, the people attacking anonymity systems, and they look for traffic patterns and stuff like that, and you can't do that by hand. So George Dns put his code during this, put his code where his mouth is during the summer school and hacked a proof of concept implementation. And this thing is really amazing. It eats away all your computing power. We now have to rewrite it to use distributed computing. It does something which is called feature extraction, which basically you throw in some 1,000 features like HTTP headers or SMTP handshakes. We did a test with, we basically dumped the probes used by SMTP Scan and used them then with this cross-core tool to find the most similar ones or to put it as input in there. So you have a dictionary with headers of that, and then this tool automatically extracts the byte sequences which most strongly distinguish the different headers and group them. Then you still have the problem to identify which of this bunch is which server. For example, with HTTP headers, you might just use the server header because you can be quite sure that there may be people who change their server header to say something different, but not the majority of web servers. So if you fingerprint some 10,000 HTTP server headers, cross-core will group some of them together, and if of one group, let's say 20,000 say they are Internet Information Server version 6, and another 80 say they are Apache, you can be quite sure that these 80 are patched Internet Information Servers, although that's very difficult with the Internet Information Server. This is example output of cross-core. Even if it's already built its database, it takes quite a long time to start up. Here it's only with a very short database of, I think, 500 or so headers. If you start it and there is no database, it rebuilds it automatically. But I wanted to present it with more interesting data for the concourse, but after 20 or 30 hours on my notebook crunching away with that stuff, I stopped the process. And then it generates output like this. It's very interesting because it's not handcrafted. Nobody would come to the idea that the content length header is the best one to distinguish servers. Cross-core thinks it is. But these are the features it identifies certain servers with. For example, the ASP session ID probably is something good to identify. And then it says what the top matches are for this server. And in fact, they are right. It was an Internet Information Server version 6. In fact, it was exactly the same server as was before used as a database in this file out 199. And the charm of that is that it can work with other protocols too. Basically, everything which is always the same, or at least likely the same, if you repeat it over and over again, and which you can dump in text files for cross-core to analyze. Yeah, this is a slide we came up after we started drinking beer. Things that broke while development. Oh, even the T's. It was quite interesting. If you do fingerprinting, you send servers borderline cases, commands which aren't that usual and aren't meant to be sent.